In today's video, we will be observing the moon and how it affects the Earth. We aim to look at three things today. We are going to look at what causes the moon phases and predict how long in between each moon phase. We are going to then look at eclipses, and we're going to see what causes eclipses and then predict when upcoming eclipses will be. And finally, we are going to look at how the moon causes the tides on Earth and then predict when the tides will occur. So as we continue, please keep those three ideas in mind. And I believe in this first video, we are going to focus primarily on the moon phases. So before beginning the discussion of the moon, I just need to review with you two key concepts about the Earth and two motions that the moon experiences as well as the Earth. The first one is rotation. As you may know, the Earth rotates, meaning it moves about its axis. It just spins around. The moon does this as well. The second motion is called revolution. The Earth actually moves all the way around the sun. The moon revolves as well. The difference between the Earth revolution and the moon revolution is the center of orbit for the Earth is the sun. The center of orbit for the moon is the Earth. So if this picture were a bit more detailed, you'd see a small little white object circling around the Earth. So again, the Earth revolves around the sun and the moon revolves around the Earth. That is a very important concept. So let's get an idea of the scale of the moon. It is very, very large, but obviously the Earth is much larger in comparison. This is a scale comparison of the way they are. And I want you to notice two things. One, notice how small the moon is compared to the Earth. While it is large, it's very much smaller than the Earth. The second thing I want you to notice is the proximity of the moon to the Earth. The moon is very close to the Earth. Think about how big space is. Space is a very large place. The moon is considered to be very close to the Earth. Because especially during the eclipses video and the tides video, you're going to see that the moon has a great effect on what we experience on Earth. And some of you may be asking, how is that possible when it's so small? And the very short answer is that it's so close to the Earth. So I want you to first start out by looking at this picture. You should see the moon moving around the Earth, the sunlight's coming from over here, and then phases of the moon appearing on the right side. The biggest thing to get out of this picture is noticing that the moon is covered halfway with light no matter where it is around the Earth. Notice that no matter what, half the moon is covered in light. You should be able to see that very clearly. Now, while half the moon is covered in light, you'll notice that based on the position of the moon, it doesn't always appear to be halfway covered in light. So the reason that this is showing, and I guess the question we need to be asking ourselves is, why is it that while even though the moon out in outer space appears to be halfway covered in light at all times, why is it that we see the moon as different shapes? And that's the question that we're going to aim to answer in the next couple of slides. Again, is why that out in space half the moon is always covered in light, but from Earth we see a moon that has many different shapes. It's either covered in light completely, halfway covered in light, or not covered in light at all. Here's a picture of the moon cycling through its phases. Someone took a photograph of the moon throughout its 29.5-day cycle, and this is what they came up with. So the moon clearly appears differently throughout its cycle, which is only about 29.5 days. So the moon appears differently in the sky throughout its 29.5-day orbit. Remember, orbit is that motion of revolution that we looked at in the past. This is orbit. So while this is the Earth going around the sun, the moon also goes around the Earth. So this process that you see right here takes 29.5 days to go from one new moon all the way around back to another new moon. And this is called its orbit. It takes 29.5 days, and these different shapes that we see as it goes through its orbit are called phases. So we've already established that half the moon is always facing the sun. And I love this picture because it shows that no matter what phase the moon is in, and these represent different positions of the moon around the Earth, no matter what, it's always covered halfway in light.
So in this model, you will see, looking above out in space, every single moon, no matter what the position, is halfway covered in light.
Angle of the Earth to the moon determines what phase the moon is in. So look at this inner circle of moons. Again, just like this last picture, no matter what position it's in, half the moon is always covered in light. Now, what the second outside circle represents is how we see the moon in each phase, in each position. So let's start with new moon. just like all the other phases, half of it's covered in light, correct? But now look at it. We see this is what we would appear from Earth. So draw an imaginary line. Imagine a line going straight from Earth, someone standing on Earth looking up into the sky. Well, are they seeing the lit up part? I don't think so. They're seeing just the dark side of the moon. They're not seeing any light at all. They're looking up at it, they're seeing just darkness. That's what the moon looks like to them, just darkness. Now, a few days later, they look up at the moon and they see mostly darkness, but now at this point they're going to see a tiny sliver of light because it's at an angle. So they're seeing mostly darkness, but a tiny sliver of light. Oh, well, look up here. This is what the moon looks like to them. Mostly darkness, but a tiny sliver of light. Now looking up here, half darkness, half light. This is what they're seeing, and this is what they're saying, half darkness, half light. Now if they're from Earth, draw a line again from Earth up to the moon. Well, they're seeing mostly light with a tiny sliver of darkness. Oh, look up here. Mostly light with a tiny sliver of darkness. That's what they're seeing. So the outside circle represents how the moon appears to us. And it all depends on our angle. So if we're looking at it directly head on, we'd see either dark side of the moon or a full light side of the moon. If we're looking at it from an angle, we see sometimes mostly light or sometimes mostly darkness.
So now you can see what the moon's orbit looks like from the side. One thing that I want you to notice right away is looking at the angle of the moon, you can see that at some points it is higher and other points it's lower. That gives us an explanation as to why we can see a full moon, because even though it's right behind the Earth, you think the Earth would block it out. The fact is that it's above the Earth, so it actually is not blocked out by the Earth's shadow. And once again, notice that each moon, no matter the position, is covered in halfway with light. So now for the purposes of this video, I've placed the camera where the Earth would be. So I'm going to turn through each phase and you'll see what it looks like from each angle. So the first phase you'll see is the new moon, followed by the waxing crescent, where only a sliver of light remains. Then first quarter, where the light is on the right and half of it's covered in light. And then waxing gibbous, where more than half the light is covered, more than half the moon is covered in light. And then finally full moon, where you should be able to see the entire moon bathed in light.
And just very briefly, here's how to name those phases. We have gibbous, means more than half the moon is bathed in light. We have crescent, which means less than half the moon is bathed in light. When the light is on the left and the amount of light is decreasing, the moon is waning. And the light is on the right and the amount of light is increasing, the moon is waxing. So you take these two words, waxing and waning, or gibbous and crescent, and you combine them together to form the different phases of the moon. So for example, if I told you, let's find a waxing gibbous, we want to find something that more than half the moon is bathed in light, and the light is on the right. So let's find a waxing gibbous. Well, here's a waxing gibbous. The light's on the right, and more than half the moon is covered in light. A waning crescent now, the light's on the left, and the crescent means that less than half of it's showing light. And here's, they're calling old crescent in this picture, but it's a waning crescent, half covered in light, and less than half is covered in light, and the left side is what's covered in light. So you can use these four words, gibbous, crescent, waxing, waning, to create the names of all the phases of the moon. We also have full moon, when it's fully covered in light, new moon, when it's not covered in light at all, and then first quarter, or waxing quarter, that's another way to remember it, when the right half is covered in light, and last quarter, or waning quarter, when the left half is covered in light. So that concludes our moon phases discussion. Hopefully you got something out of the video. Please take notes and write down any interesting information you collected.